Welcome to EDU World Space.
It is mentioned in the problem that a bob of a pendulum is given a sharp hit so that it acquires a velocity v0 equal to under root of 10 gl, where L is the length of the pendulum and g is acceleration due to gravity. We have to find the tension in the string when it is horizontal and when it is making an angle of 60 degrees, and also when it is at its highest point. So we will solve the first part of the problem A, when it is horizontal. When the string is horizontal, there will be one force mg which will be acting downwards. So let us do it with this color. There will be one force which will be acting downwards, and there will be one force, the centripetal force, which will be acting towards the direction of the tension. Therefore this will be the tension. So because mg, which is perpendicular to tension when the string is horizontal, this particular force mg won't have any component perpendicular to it that is along the direction of tension. So the force along the tension will be T is equal to mv squared by r. Now we want to find the velocity this bob will acquire when it is horizontal. For that we will use the conservation of energy. Conservation of energy. So we will have half mv0 square is equal to mgl plus half v square, half mv square. So we consider this to be h equal to 0 and this to be h equal to L. So this is the base, the ground level, when the bob is at its initial state, and when it becomes horizontal it is at an elevated state where h is equal to L. So using the conservation of energy, initially it has a kinetic energy of half mv0 squared, where v0 is equal to under root of 10 gl, and v is the velocity when it is horizontal. Therefore half m under root of 10 gl whole squared is equal to mgl plus half mv squared. Cancelling m, we get 10 gl by 2 is equal to gl plus v squared by 2, implies this will be 5 gl minus gl, 4 gl is equal to v squared by 2. V is equal to under root of 8 gl. Therefore T is equal to mv squared by L. R is equal to L, equal to m by L of v squared root 8 gl whole squared, which is equal to 8 mg. T is equal to 8 mg. This is the answer to the first part of the problem. Now we will solve the second part. When the bob is at its highest point. When the bob is at its highest point, it will be something like this. So there will be a force acting in this direction, mg plus mv square by r. Both the centripetal force and mg will be acting in this direction. Therefore we will have, although the centripetal force will assist in the circular motion, the tension will be minimized. There will be a negative sign here because it will be in the opposing direction, because it will be mg, and mv square by r due to reactionary force will be acting along this direction. Therefore it will be the total tension, implies T is equal to mg minus mv squared by r. Now we have to find the value of v. Again, using the conservation of energy, of using this principle, we have half mv naught square is equal to mg into 2l plus half mv squared, implies half m under root 10 gl square is equal to mgl plus half mv square. Cancelling m, we have 5gl is equal to 2gl plus v square by 2, implies v square is equal to 6gl, implies v is equal to under root of 6gl. So this is the velocity at the topmost point. Therefore the tension will be mg minus m by l, as r is equal to l, into under root of 6gl whole squared, which is equal to mg minus of this will be 6mg, implies T is equal to 5mg. We are considering the magnitude because direction wise we are considering this to be positive and this to be negative. Therefore T will be equal to 5mg. And finally, when it is making an angle of 60 degrees, so this will be the third part of the problem, when it is equal to 60 degrees. Alright, so when it is 60 degrees, so this is 60 degrees, mg, this will be mg cos 60, and this will be the direction of mg sin 60. This will be tension, T will be equal to mg cos 60 plus mv squared by r. Alright, so we have to find the velocity of v again, so we will use the conservation of energy again. Conservation of energy, half mv naught square is equal to mgh plus half mv square. Now this length is h, so we can calculate the value of h. This is L, so this will be L cos 60, implies h is equal to L minus L cos 60. L minus L cos of 60 is half by 2. So this is not according to scale, but h is equal to L by 2. Therefore v naught square by 2 is equal to gh plus v square by 2, cancelling m. Squared by 2 is equal to g by 2 plus v is under root of 10 gl. I apologize for this. This will be v square by 2 only because we are finding v. This will be under root 10 gl by 2 equal to gl by 2 v square by 2. Therefore cancelling all the denominator 2's, we will get 9gl is equal to v squared, implies v equal to 3 under root of gl. Now we have found the value of v, therefore we will find the value of tension equal to mg cos of 60 plus mv squared by l equal to mg by 2 plus m by l into 9gl equal to mg by 2 plus 9mg, which is equal to 19 by 2 mg. So this is the answer.